Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop. We're working on an LBSC Tich locomotive and the boiler. In this week's episode we'll talk about making the water fittings for the boiler, aka clacks. So stay tuned, I hope you enjoy it. Thanks everybody. Hey folks, for this episode we're going to be working on making the water check valves for the boiler. There's one on either side, and I wanted to show these because these are kind of the jewelry for the locomotive. Here's some bling up here, but they're pretty noticeable, and I'm going to go the extra mile on these. Part of the reason is that LBSC even talks about making the caps. This is a blow-up picture from inside the book, and he wants you to take and file a little square on the top of this to make it match the prototype locomotives. And by the way, this is a trick that I learned from Tinker John. If you may be familiar with his channel. I really like his channel. Many years ago he built a Stewart 10, I think it was, vertical engine, little Coke bottle engine, and he showed that this technique he does where he blows up a picture, tapes it in, and then he can draw and make his own notes on there. So I really like that. I copied that. So the boiler check valves, instead of just making the body out of 5/16 inch brass and then the adapter part out of hex brass, I will make 5/16 inch hex brass adapters to screw it into the boiler. But I got to thinking about it, considering that this is a very visible piece here, rather than just using a piece of plain brass, which you got to look at this, it's gives a kind of a plain Jane appearance. Let me show you another photograph. I mean, you can notice the connectors more, but that's really kind of a plain appearance. And rather than doing that, I thought I could go the little extra mile, use some of these PM Research castings. A casting tree is what they call them. They're not very expensive, and they come in all different sizes. This size is what they call 1/4 inch. The body of it is just about 5/16 inch, so I think it's going to be perfect. I'm going to cut 2 of these off on the bandsaw. I will still have to make some adapters, so actually a little bit extra work, but I think it'll be worthwhile. I think it's going to look really cool. So stay with me, and let's see what how this comes out. Here's the parts fresh off the bandsaw. Just cut them off. I touched them to the belt sander there. Just cut them off flush on 2. These ones I left long because it wouldn't hurt to have a little extra material at the bottom. Too bad it's not a lot more. I could make the adapters for the water connections. There's what the T looks like after you cut off a couple pieces. And I just want to show, here's the boiler, just to give you a kind of life-size view. Of course my clumsy fingers are in the way. It's going to look kind of cool. A little bit more like something rather than just a little tube. Here we are making the first of the 2 little adapters that'll go with. This is the part, the 7/32 40 threaded portion that'll go into the boiler. And as you can see here, I did make a little undercut because it's not the threads that make the seal, it's really the flat against flat, as we saw when we did the boiler test with the steam dome. So you don't want that last bit of threads that keeps it from engaging the flat part on the boiler. So that side is done. I drilled a number 40 hole deep enough so that when I cut it off, that hole will be part of the cutoff. Now then I can make another one of these blanks, and then I'll have 2 the same length that I can machine. Okay, here's one of the T's. I haven't machined this one yet. I haven't done either one of them yet. But these are bottom fittings here, where the water connections will come in. So the ball seat will be on the top part here, smaller thread that's a 7/32 40. So I do need to make a ball seat in that once it's together. And then it's 1/4 x 40 threads on the bottom part here. And I've got the second one made. I'm getting ready to put the undercut in for the threads there for the 1/4 x 40, and then I'll use the tailstock die holder to put the threads on it. Happily, I had made a jig for making ball valves from the PM research kit, and the neat thing is I can use a half of that jig to hold the T, one of the T's, in a nice stable position, so I've just drilled it and tapped it. Here's the jig I was talking about. Actually made this to do the globe valves, but it's going to be really handy. I finished using it for the other one, and now I just got to drill and tap the top portion for this one. Okay, here's the little PM Research T-fittings, loosely fitted together with the boiler adapters and then the water adapters at the bottom. Pretty pleased how all this came out generally, although I think I may remake these parts with the boiler. I don't believe this is supposed to stick out so far from the boiler, but that's easy. There's material left. I could remake that, machine that a little bit. I'll study on that distance and perhaps remake that. Here's a kind of an exploded view, if you will. There's the machine T. I tapped 3/16 inch 40 here, and this is the adapter, the side fitting that screws in there, and then the water adapter, which is 7/32 40 on the inside and 1/4 inch 40 on the outside. I do like the look of it, so pretty pleased about that. And also the jig was very helpful. This is what the jig looks like with the globe valve in it, and I was able to use this for the T's just by using 1/2 of it. And here's the, like, that's what it looks like when you use it for the globe valves, and there's screws to hold it together. But it's pretty handy. Really glad I used that, because when I tried to do it in the forejaw, I thought I had this thing centered, and obviously it was way off. So this will be a scrap or other thing, but using the jig in the mill worked really well. But I do think that's going to stick out too far. I think it's probably, that's going to have to be reduced a good bit, which is not a problem. Always have an extra material, make it easy to remove some, and then of course I got to make the caps on top. After that test fit, I decided to thin this out by about half the distance, so it's about 1/80 thou width versus 3/16, and it looks a heck of a lot better. I think that's going to be perfect. So next up I'm going to do this one. LBSC talks about making custom mandrels for things, and it is a really great idea. So I used this a second ago to modify the other one. So now I've got this, and I'll tighten this up with a wrench, and then I can shorten this part and this the nut part there, just like I did the other. But it's nice to have the little threaded mandrel, gives you all that working room. I'm making the top parts for the clacks, and this is just a piece of 5/16 inch brass. I've turned it down to 0.219 here, getting ready to thread it, and I made the little undercut there where my thumbnail is, so that it'll make a nice seal on the top part. And I just touched a file to the bottom here to give it a little lead in for the threading. So I'm going to thread this, and then I'll cut it off. I'll make another one just like that, and then I'll use my little fixture to turn the top part down, get ready for final machining. Here's the little blanks for the top. They're threaded 7/32 40, and they're long enough that that will provide a 32nd of an inch of lift on the ball when they're installed. I'm using the little fixture that LBSC describes. It's a little threaded fixture that's very handy. You definitely want to make one of these if you're doing this project. Now I'm going to take this out, put it in the mill, and mill the little top round part to a square shape. Okay, there's the first little square machine. They use the 5C collet and a square chuck in the mill. Not too bad, not too great either. Got the other one to do. In case you're interested, this is the setup for the milling, and this is the second one, and it came out really nice. Here's the two finished water valves. I say finished, I still need to silver solder them in. I decided I'm going to go ahead and silver solder both the upper and the lower portions. But one thing you want to do is I put the balls in there, and I don't know if you can hear it or not, but I held this up to my ear and I could hear the ball moving. And I'll stick a piece of wire in there and make sure I got a 32nd of an inch lift. And I'll clean this all off and then silver solder it all together. and then polish it up. I realized I could actually unscrew the side that mates into the boiler before I solder it, and you can see the ball in there and the space that it has for lift. It's a good 32nd of an inch. And then you need the lift space for the water coming in, obviously, but you don't want too much excessive space because you don't want the ball to get trapped anywhere else. And here's the valves silver soldered together on my little handy fire brick piece. Now I'll soak them in the paint. Alright, here's the completed clack valves. Pretty happy with how they came out. Hope you like this episode. This will be the last little segment for this week. And I hope you like making boiler fittings, because you're in for a treat if you do. We'll be making a lot of them, and it should be a fun project. I really enjoy making these kind of things, and excited about it. So hope you have a great week. Please give me a thumbs up, subscribe, help pass the word. I appreciate it.